Hello class, welcome to our next lesson dealing with linear and angular speed. The next 3 days worth of lessons all come from a worksheet kind of set that I have posted and given out. The answers to all the questions from that worksheet are also going to be posted. I'm planning to go over a few of those questions and then leave some others to you to try to solve. But you'll have the answers with you so that you can see if you're on the right track. And these also correlate to a lot of your homework questions that you'll see as you're looking at this chapter. So the first question we're going to look at is the second day's material number 3, where they give you a bunch of information and say solve for S. So for this question, what you want to start with is the fact that r and omega, okay, the angular speed and the radius are given to you. And then you'll find the velocity by multiplying r and omega together. And then once you have the velocity, your goal is to find s. So you have two options. Either you could do s equals r theta, which you could find theta using omega in time. That would be okay. Or you can use it, find velocity and time, and find the arc length s by using that equation. So since I already solved for velocity or linear speed, I might as well use that to solve. And then I would just multiply the 9 to the other side. You'll want to pay attention to if your answer needs to be in a fraction. If it's a fraction, it probably has pi in the answer. If it's a decimal, it probably multiplies the pi in. To be honest, a lot of these questions you're probably looking at the second version if you think about application-wise. But some of them ask you to just leave the answer in terms of pi. But again, I had to use the velocity equals r omega formula. Solve for v, which is the linear speed, plug that into the v equals s over t formula, and solve for s. The next question is a set of questions dealing with clocks. This is find angular speed. Remember, angular speed is the angle divided by how much time. So for the angle, or for the second hand, the angle goes all the way around, or the second hand goes all the way around 360 degrees in 60 seconds. So one revolution is 60 seconds. Now the key with one revolution is always 2 pi radians or 360 degrees. So that means that my angle is 2 pi radians in every 60 seconds. And I just simplify that and I get pi over 30. Any of these questions, it should be 2 pi divided by how long it takes, and then just simplify it to figure out the angular speed of the second hand. The next question deals with number 9 from that same day's worksheet. It says the tip of the second hand of the clock, the hand itself is 28 millimeters long. That's the radius. And you're trying to find the linear speed. Okay, that's kind of going around the edge of the linear speed, how fast it's going around. The issue with this question is you should use v equals r omega. Well, they give you r, that's 28 millimeters. We actually gave you omega in the previous question, number 5. So omega, remember, is the angular speed, and the angular speed of the second hand was 30 over pi radians per second. So I'm just going to plug that in here and simplify a little bit, and I'll get 14 pi over 15. Probably because it's linear speed, you're going to multiply that through and get 2.93 millimeters per second. So what that's saying is if you were on the edge of the second hand, and you could expand this to any circle, you're moving that fast around the edge as you're going through. Make sure that you look at the angular speed questions first for today's information in order to figure out the linear speeds. The next question deals with the tip of a propeller. It's 3 meters long, so the propeller right there, 3 meters long is the radius. And then you need to find omega. Omega can be found very quickly. 500 rotations per minute, that would represent 500 times 2 pi, because every rotation, every revolution, every orbit, every time around the circle one time is 2 pi radians. So most of the time, if you see rotate so many times, just multiply it by 2 pi, because one revolution is 2 pi radians. And this will end up being 100 pi radians per minute. So you just take the 3 times the 100 pi, and that would get you 300 pi, or just about 942 meters per minute. So that's really moving. Now, if they ask you for per second or per hour or something different, you're going to have to adjust and use your unit conversions in order to get through from those scenarios. Make sure that one revolution is 2 pi radians, And then use v equals r omega in a lot of cases. If they give you the radius, it's probably that idea. If they give you arc length and time, then you probably want to use the other formula. Make sure you check some of those other questions in order to be successful for the homework. If you have any issues with how to find some of the answers, let me know. Maybe we can talk about it some. But most of today's deal with this type of situation with angular speed, linear speed, and v equals r omega. Have a great day, everybody.